Welcome to The Explainer. Today, we're diving into the incredible story of a single scientist from the 19th century. And believe it or not, his work actually answers two massive, and you'd think totally unrelated, questions about the world we live in.
All right, first up, a question that's pretty much impossible to avoid these days. We tend to think of climate science as a modern thing, right? Something from the last few decades. But you'll be surprised to learn its roots go way, way further back.
And then there's this one. It's a question so simple a kid might ask it, but the answer? It's just this beautiful piece of physics that we see playing out above our heads every single day.
So, here's the kicker. What if I told you the answers to both, a warming planet and a blue sky, actually come from the curiosity of one single person working over 150 years ago? It sounds crazy, but it's true.
Okay, so let's get into it. The man at the center of this whole story is an Irish physicist named John Tyndall.
So check out his journey. He started out as a surveyor in Ireland, but his brilliance took him all the way to becoming a top professor in London. And then, in 1859, that's the T year, he builds this thing, his radiant heat apparatus. And it's this device that would completely change how we understand our own atmosphere.
Okay, let's talk about his first massive breakthrough. Tyndall was obsessed with a fundamental question. How does our planet stay warm enough for life? And his work led him right to the discovery of the greenhouse effect.
What he did was genius. He started testing different gases to see which ones could trap heat, and he was the first to prove, experimentally, that gases like water vapor and carbon dioxide were the real heavy lifters. They basically act like an invisible blanket for the planet, trapping just enough heat to keep us from being a frozen rock in space.
So here's how it works, in 3 simple steps. First, the sun's energy comes in and warms up the Earth's surface. Easy enough. Then, the Earth tries to radiate that heat back out into space. But, and this is the crucial part, those greenhouse gases, like CO2, they absorb that outgoing heat. They trap it. Without them, all that warmth would just, poof, vanish into space.
And this is why his discovery from the 1800s is so incredibly important today. Since the Industrial Revolution, we've been pumping more and more of these heat-trapping gases into the atmosphere. We've basically been thickening that blanket he discovered, which is amplifying the warming effect he was the first to identify.
But Tyndall wasn't a one-hit wonder. His curiosity was huge. After figuring out heat, he turned his sights on another massive mystery, light itself. He wanted to solve that age-old question, why is the sky blue?
And here's the core idea he helped figure out. Sunlight might look white to us, but it's really a whole spectrum of colors, right? A rainbow? He showed that when that sunlight hits all the tiny molecules in our air, the shorter wavelengths, the blues and violets, get scattered all over the place, way more than the longer red and orange wavelengths.
Now you might hear a couple of different names for this. When light hits super tiny air molecules, we call it Rayleigh scattering. That's what gives us the blue sky. But when it hits slightly bigger particles, think smoke or fog, that's what we call Tyndall scattering. It's basically the same idea, the only real difference is the size of the thing the light is bumping into.
This chart really lays it out perfectly. Look at the particle size. When it's super small, less than a nanometer, like air molecules, you get Rayleigh scattering, and boom, a blue sky. When the particles are a bit bigger, in that colloidal range, you get Tyndall scattering. That's where you see the blue in smoke, or even in blue eyes. And then, when the particles are really big, like water droplets in a cloud, they scatter all the colors pretty much equally. And what happens when you mix all the colors of light? You get white. That's why clouds are white.
So you see this everywhere. The blue sky? That's blue light scattered all over. A red sunset? That happens because the sun is low, and its light has to travel through way more atmosphere. By the time it gets to you, most of the blue light has already been scattered away, leaving just the reds and oranges. And this one's my favorite. Blue eyes don't actually have any blue pigment in them. Their color comes purely from this Tyndall scattering effect happening in the iris. How cool is that?
Okay, so now for the really unexpected part. We're going to connect Tyndall's work from the 1800s to something super modern, taking us from the physics of the atmosphere all the way to the world of cosmetic aesthetics.
Yeah, you heard that right. This is where the story takes a really wild turn. The exact same physics that explains why the sky is blue is now a term used in modern medicine to describe a specific side effect of cosmetic procedures.
It's literally called the Tyndall Effect. See, dermal fillers are basically gels that have lots of tiny particles suspended in them. If that filler is injected just a little too close to the surface of the skin, it can cause this strange bluish tint.
And now you know exactly why it looks blue. It's the same process we just talked about. Light goes through the top layer of skin, it hits those filler particles, and just like in the air, the short wavelength blue light gets scattered back towards your eye more than any other color. The result? A visible blue hue.
I mean, it's just a perfect example of how a fundamental discovery about how the world works can have applications that the original scientists could never, ever have dreamed of. Who would have thought a principle explaining the sky would end up being relevant to modern medicine?
So, from the warming of our entire planet, to the color of our own eyes, to the unexpected challenges of cosmetic science, John Tyndall's incredible curiosity really left a huge mark on our world. It's just an amazing reminder that investigating the invisible things all around us can totally change how we see everything.
And that really leaves us with a final thought, doesn't it? Tyndall was just trying to figure out heat and light. He had no idea his work would be central to conversations about climate change or aesthetics 150 years later. It really makes you wonder, what fundamental discoveries are happening in labs right now that will unexpectedly define the world of tomorrow?